Welcome back. In this video, I will talk about the governance of closed-loop supply chains for energy materials and the data management needed for circular renewable energy technologies. Back in the 70s, supply chain management came up as a business strategy for resource flows to facilities and products or waste flows from facilities. Sustainability and resource efficiency have transformed the traditional supply chain management from a purely linear approach to a closed-loop approach, meaning that feedback loops are introduced, resulting in circular supply chains. And this includes reverse logistics, take-back procedures, quality checks, data management, and many more socio-economical aspects. In this presentation, I will further explore what we mean with the governance of closed-loop supply chains and how proper data management plays a role in that. To address this topic, I will follow the Circular Economy Feasibility Evaluation Framework by Angelos Kofos and al. This research by TU Delft, in collaboration with a couple of key partners from businesses and governmental organizations, has identified what is needed in terms of data along the supply chain of circular products. And this approach also applies to circular renewable energy technologies and energy materials. At the bottom of this picture, we find a partial summary of the supply chain from consumption and use to materials sourcing. For example, let's assume this is about a set of solar panels, including a PV inverter and wiring, and that's all needed for a full installation. After the installation is completed and the solar panels are used for several years, at some moment the panels are taken back. And that's the moment that the installation will be dismantled and will go into the return center, which can be local or centralized. And from here, materials can go into recycling and end as a new material source. However, as we have seen before, the products can also go into other steps of the so-called R ladder. For example, repair or remanufacture, and then be brought again into use. In each following step, from product acquisition to centralized return center to recycling process, and finally materials resourcing, transportation and handling activities are required. And all these steps in the supply chain and the logistics chain will be accompanied by description of the item, the package, the lading, and the type of transportation. In most cases, all this information is already available somewhere. The main challenge for circular economy is to make this information available in such a way that proper governance can take place. In other words, data has to be provided to turn linear flows into circular flows. In this full framework, it becomes visible that supply chain management, logistics, reverse logistics are highly intertwined. Documentation is needed for each singular step, not only for product specifications, but also for compliance and, as we call that, digital product passports. And this requires a well-defined governance and semantic data platforms that are available for at least the product lifetime. In the references to this week's reading, more information is added about the European projects DataPipe and Titan that have used these principles to define the data acquisition and architecture of data platforms for a circular economy. In conclusion, supply chains are more and more evolving into closed-loop systems, incorporating reverse logistics and take-back procedures. This also affects renewable energy technologies with regards to sustainability-focused data management. Effective governance of circular supply chains require comprehensive data collection and sharing, supported by frameworks like, as we presented, the Circular Economy Feasibility Evaluation Framework. And this includes digital product passports and semantic data platforms to ensure traceability and compliance throughout the product lifecycle. Projects such as DataPipe And Titan highlights the importance of technical innovation, market design, user behavior in achieving sustainable outcomes.